Hello my friends and welcome to this quick revision in your favorite subject, chemistry. Today we are going to finish talking about the electronic configuration and the two types of electronic shells, answering the questions we took in the previous class. Allow me before we answer these questions to give you a quick revision for the things we have taken in the previous class. Well, in the previous class we have talked about the two main parts of the atom, and we said that the first one is called the nucleus, inside which we have positive protons and neutral neutrons, and the other part is called the electronic shells or the energy levels, inside which the electrons of the atom are distributed. And then we said that each shell has a name. For example, shell number 1 is K, shell number 2 L, shell number 3 M, and shell number 4 N, while shell number 5 O, and shell number 6 is called P, while shell number 7 is called Q. And then we answered a very important question, which was how many electrons each shell can take. And we said that this is called the capacity rule or the capacity equation. A capacity equation is 2 multiply square n, where n is the number of the shell. For example, shell number 1, K, can take 2 electrons according to this equation, while shell number 2, L, can take 8, shell number 3, M, can take 18, shell number 4, 32 electrons, while shell O or number 5 can take 50 electrons, while shell P 72 and shell Q can take 98 electrons. Then a student of mine asked me this question. Teacher, we all know that the shells here, or the energy levels, are different in terms of energy. For example, K has the lowest energy, then N higher energy than K, and M has higher energy than L and K, and N has higher energy than M, K, and L. Each question was, does each electron inside the same shell have the same distance to the nucleus? And we said, and the answer was no. Generally, my friends, the electronic shells or the main electronic shells are divided into subshells, which means that not all of the 8 electrons in L have the same distance to the nucleus. Some of them has higher energy and they are closer to M, while others have lower energy, which are closer to K. Then we discussed the matter of the subshells, and we said that shell K, which is the shell number 1, has only one type of subshells, which is called 1s. Here, number 1 refers to the main shell that the subshell belongs to. And as we all know, shell number 1 can take 2 electrons, so we put them into one cell. Again, my friend, shell K, which is the first shell, has one type only of subshells, and it's called 1s. The number 1 refers to the main shell that this subshell belongs to. As you see here, clarified in this example, this is the main shell number 1, and it has only subshell 1s. While the second shell, L, which has number N number 2, has 2 types of subshells. The first one is called S, the other one is called P, and again here the number 2 refers to the main shell that these subshells belong to. And then we said that, as you see here, 2s and 2p. Again, my friends, 2p has higher energy than 2s, and it's closer to M than K. As you see here, the subshells are like stairs from one shell to another. So they are different in their energy because they have different distances to the nucleus. For shell M, which has the number 3, we have 3 types of subshells. We have a 3s and the 3p and 3d. Again, my friend, This number 3 refers to the main shell that each one of these subshells belong to. And then, my friend, we said that S can take 2 electrons. Here, shell number 1 can take 2 electrons. Shell number 2 can take 8 electrons. 2 of them in 2s, while 6 of them go to shell B. For shell number 3, which is M, we have 18 electrons, 2 of them in S, 6 in P, and we have 10 of them in D. Generally, when we fill these subshells, we have to start putting 1 electron in every cell, then we make them pairs, but because I was in hurry, I filled them together. Then, my friends, we said that if you count here 2, 6, 8, 10, 18, and we have here 8, and we have here 2 electrons only. Then, my friends, we have talked about the electronic configuration, and we said if we want to distribute the electrons of an atom on the electronic shells, we have to start from the lowest shell, K, then we go to L, then subshells in L, then we finish and we go to subshells in M, then we go to N and O and so on. In here, my friends, I am going to give the electronic configuration of some elements. I start with sodium. Sodium has 11 electrons. First of all, we give 2 electrons here, so we still have 9. Then I give 2 here, we still have 7, because 4 and 7, 11. Then I put here 6 electrons, because P can only take 6 electrons and S can only take 2 electrons. But as long as I have put here 2, 4, 6 becomes 10, and I have only 1 electron to distribute, so S can take only 1 electron. And the other shells here, the shells which are empty and don't have any electrons, I delete them, because those shells are empty. And here, my friends, we say the valence shell, of sodium is shell number 3, which is called N shell, and it contains 1 electron, and this electron is in 3s. Again, we have sulfur, 32 electrons. I start distributing the electrons from the shell K, which has the lowest energy. Give 1s, 2 electrons. We still have 30. 2 electrons here, we have 28. 6 electrons, we still have 22. Again, here I put 2 electrons for 3s. We have 20. I give 6 here. And again, my friends, as you all know, I start filling from 4s, then I fill 3d, because generally 4s has lower energy. So I start 1s, 2s, 2p, 3s, 3p, then I go to 4s, then 3d, and then 4s. Here we have 2 electrons. Count with me, please. 2 and 2, 4, 6, 10. And here we have 18, as you all know. Third shell has 18. Here we have 20. Then I add 30 now electrons, my friends, and I add 2 electrons. A lot of students told me, teacher, but 4p can take 6 electrons. Why you have only put 2? Generally, my friends, we have 32 electrons that should be distributed over those energy levels. So when I distribute, while distributing them, I have only here 2 electrons to put. If I had more electrons, I would add them. So we have here till here 18 electrons. We have 28, 30, 32. So what is the valence shell here? Yes, the valence shell has number 4, N4. So the valence shell is N, shell N, big N, of course, capital N, sorry. And how many electrons can we find in the last shell? We have 4 electrons in the last shell. Why 4? Why didn't I take only the last one? Because again, number 4 refers to the main shell that those subshells belong to, and we count them together, so the last shell has only 4 electrons. The next element, my friend, is iron, which has 26 electrons. Let's distribute them on the subshells here. We start with 1s. We give 2 electrons to this subshell. Then we go to 2s, 2 electrons. We lost so far 4 electrons, so we still have 22. We add 6 electrons here. We still have 16. We add 2 here. We still have 14. We add 6 here. We still have 8 electrons. I give here 2 electrons, and I guess here should be again 4, 10, 18, 20, and we have here 6 electrons. So then, my friends, we go to copper, which has 29 electrons, 2 here, 2 here, 6, 2. Here we have 18. We still have 11 electrons. I give here 6. I still have 5 electrons, 2 here, and again 10, 18, 20, and 9 electrons in 3D. So last shell is N equals 3. For zirconium here, my friends, we have 1s, 2 electrons, 2s, 2p6 electrons, 3s, 3p6 electrons. We add here 2 electrons, and here we have 10, so 30 electrons. We still have 10 electrons to distribute. I have here 4d. I give here 6 electrons and 4 in 4d. So the last shell is N equals 4, which is shell KLMN. Here we have last shell M, and here last shell N. A lot of my students have been complaining about this topic, and I cannot deny that it is a little bit complicated. It needs hard studying. But after repeating this video 1 or 2 times and playing some Kahoot games which are related to this topic, I promise you that everything is going to be okay. In the next classes, we are going to talk about cations and anions, and then you are going to see that this class is very important, and I will mention in these classes that if you want to study, for example, I think class number 14, if you want to study class number 14, you have to go back to class number 7, part 1 and part 2, to watch them, and then you come to class 14, because these topics are very sensitive and very important for the next classes. Again, my friends, if you have any questions, you can get in touch with me, you ask me, and play some Kahoot games which are going to be very beneficial for you. Thank you again, my friends, and see you in the next classes.